this is FlippedHarber for Physics. In this video, we're going to go over practice problems on page 69, numbers 26 through 29. Number 26, we have a skateboarder moving at a constant velocity of 1.75 meters per second when she starts up an incline that causes her to slow down with a constant acceleration of negative 0.20 meters per second squared. How much time passes from when she begins to slow down until she begins to move back down the incline? Now, they don't tell us our final velocity in this problem. We actually have to know what it is. When something goes up a ramp, slowing down, eventually, as long as it's got enough room on the ramp, it's actually going to come to a stop just for an instant before it starts to roll back down the ramp. So we're actually going to use 0 for our final velocity. So we're finding the time for the skateboarder to move up the ramp and stop just for that instant. And then she'll roll back down. But we're going to stop our whole problem when her final velocity is 0. So we know our VI is 1.75. We should understand, we should know without them telling us that our final velocity is 0. They give us our acceleration is a negative, because she's slowing down, 0.20. We're finding the time. Now, basically we're going to use the equation for acceleration, but we're solving it for time. So change in velocity divided by acceleration. As long as we plug in all of our numbers in the appropriate spot, in the appropriate order, we're going to end up with a positive time here. If you ever end up with a negative time, check your work. Negative time doesn't make sense in a physical, real-world application. So it might be as simple as going, yeah, I did it right, I just forgot the negative, or yeah, I did it right, I flipped up my velocities though. Then just throw that negative away. But recheck your work if you ever get a final velocity, a time that's negative. So we find out that the time is 8.75 seconds. Now, that's a great answer, but if we look back at our problem, as we should do, and check out our sig figs, there's 3 sig figs in the first number. The 1.75 has 3 significant digits. The acceleration, only 2 of those numbers are significant. The first 0 is not significant. The 2 and the 0 after it are significant. So that number only has 2 sig figs. Our answer, therefore, can only have 2 sig figs. So I'm going to take the 5 out. It's going to round up the 7 before it leaves. And my time that I'm going to report is 8.8 seconds. All right, let's move on to number 27. A race car travels on a racetrack at 44 meters per second and slows at a constant rate to a velocity of 22 meters per second over 11 seconds. How far does it move during this time? Now, there's a couple different ways to approach this problem. One of them, we don't need to know acceleration. One of them, we do need to know acceleration. I figured I might as well do the one where you need to know acceleration, because sometimes you've got to actually do some math to find out a number before you can plug in and find your answer. Now, this is not the only way to do this problem, but labeling what I know, what I'm looking for, first thing I'm going to do is I'm going to find my acceleration. Just take a change in velocity over time. I find out that this car has an acceleration of negative 2 meters per second squared. Makes sense that it's negative because it says that the car is slowing down. Now, I'm going to plug into this equation. And it looks a little bit different than it does in the book because I'm taking my DI to be 0. That's very common, very typical to take DI to be 0. That's not always the case, but it's very, very common. So I plug in my initial velocity, I plug in my time, I plug in my negative 2 that I found for acceleration, and I find out that the final displacement is 363 meters. Again, I can only have 2 sig figs though. 44, 22, and 11 all only have 2 sig figs. So that 3 is going to leave at the end. It's not going to round the 6. And I report 360 meters as my final displacement. So that's how far the car went. Number 28, a car accelerates at a constant rate from 15 meters per second to 25 meters per second while it travels a distance of 125 meters. They want to know how long does it take to achieve this speed. So we're looking for a time here. Now, again, we don't know acceleration. Instead of finding the acceleration, though, let's do a little bit different. We're going to take our known quantities. Actually, we're going to take two of them, our initial velocity and our final velocity, and we're going to find our average velocity. Now, the average, if you want to find the average height for people, you add them all up, you divide by however many there are. Same thing with this calculation. We're going to take our two velocities, add them together, and divide by 2. We find out that our average velocity is 20 meters per second. Now, this is totally safe and legal to do as long as there's constant acceleration. If this were a car that's speeding up at a constant acceleration, if it's slowing down at a constant acceleration, this is legal to do. This is not legal to do if the acceleration is changing or changes anywhere in between. This is only legal during constant acceleration. Now, we know that distance or displacement is equal to our average velocity times our time. Well, if we solve that for time, we find out that we need to take our displacement and divide by the average velocity. So, plug in our our distance or our displacement of 125 meters, divide by 20 meters per second, and we find out that it takes 6.3 seconds for this car to accelerate from 15 to 25 meters per second. All right, let's take a look at number 29. A bike rider pedals with constant acceleration to reach a velocity of 2.5 meters per second over a time of 4.5 seconds. During the period of acceleration, the bike's displacement is 19 meters. What was the initial velocity of the bike? Again, we don't know what the acceleration is. We can do this without the acceleration. Here's our quantities that we know and what we're solving for, VI. Here's our equation for displacement during acceleration. It takes our two velocities and adds them up and divides by 2. So that fraction in front is just our average velocity. We take that and we multiply by time, and that will find a displacement or a distance. Now I want to solve this for VI. So I multiply the 2 over, I divide by the time, and the last thing we do is we subtract the final velocity over. Plug everything in, type it into our calculator, and we get 0.944 meters per second. Now again, looking at my numbers that they give me, I see 2 sig figs in all 3 numbers. 2.5, 4.5, and 19 all have 2 sig figs. So my answer's only going to have 2 sig figs in it also. It looks like I got a typo up in my sentence, but oh well. So my final answer is 0.94 meters per second. All right, so that's the end of that. I hope that it has helped, and it's time to get to work. I'll see you in class, and I'll see you online.